Hello and welcome to another video of Learn with Vishram Bastala. Today we'll be learning about vector in class 10 OPT Maths. So what we have is two planes moving in different direction. One is coming down and are landing, and another plane is taking off. What is the direction of the plane when it is flying? So most of this vector might be used in airways or something like that, because it's all about direction and the distance and where it is going. So scalar and vector, there are two things. Scalar means only the distance, whereas vector means it is a combination of distance and direction. Alright, so scalar or dot product of two vector. Study the given graph and answer the following. What is the coordinate of A and B? What is the position of vector of A and B? So coordinate and vector of A and B. So what is the difference between that? So dot product of A and B. So dot product of A and B is A vector into B vector cos theta. The different distance, the angle between them is the dot vector. So again, discuss the question. So this is all the questions. Now, geometrical interpretation of a scalar product. So we are mostly talking about scalar product. Even though two points are vector, we take the scalar product as the multiplication of two vectors into cos theta. Alright, so what it says, let OA equal to A vector and OB equal to B, and let theta be the angle between the two vector A vector and B vector, and A and B draw AD. So let's draw AD. What is A and D is this perpendicular. Okay, so this is D. And BE, so B is also perpendicular, then OB. Now A dot B vector, A vector B vector cos theta, which is also AB cos theta. AB भनेको हो AB, AB, AB is OA into OE, correct? OB cos theta. OB cos theta means OE. Okay, yes, that's correct. So we can say that vector AB, scalar vector, scalar product of AB is magnitude of A vector into projection of B vector on A. Similarly, we can write like this too. So projection of A vector on B, or B vector on A. So since the scalar product of two vector in the product of magnitude of one of the vectors and the projection of second vector on the first, when two vectors A vector and B vector are perpendicular to each other, the angle between them is 90 degrees. If the two vectors are 90 degrees, then the sum is 0, and if they are, okay, let's not talk about parallel. Scalar. So we learn about the scalar product of two vector. So that is when it is 0, there can be two conditions. If this angle is 0, okay, angle is 90 degrees, sorry, if the angle is 0, then their product is 1. So scalar product of two vectors in terms of their components. For example, let A be a vector of x1, y1, and B be the vector of this, and a vector in the form of this I and j. We can write this like this too. Okay, so got it. We multiply it, right? Okay, I भनेको okay, putting 0. What are we doing here? So so we can write like this too. So if A and B are like this, so we can write A1 x1 x2 plus y1 y2, product of them written in the this, and this is also another formula. Cos theta equal to A vector B vector A got the head x1 x2 plus y1 y2 divided by AB. We can write like this also, length of vector. If A vector is x1 y1, then A vector be A vector into A vector is x square plus y square. A square equal to A vector into A vector, which is equal to x1 square plus y1 square. So A vector square equal to A square equal to A into A equal to x square plus y square. Properties of scalar vector competitive. Properties of scalar product. A into A भनेको चाहिँ B into A हुन मिल्छ रे, and यो पनि हुन्छ रे, डिस्ट्रिब्युटिभ पनि प्रपर्टी हुन्छ रे. सम अल्जेब्रिक रिलेसन A plus B whole square, this is also true, and similarly, okay, so square भन्ने बित्तिकै we can write square भन्ने बित्तिकै यस्तो हुन्छ है, यसको स्क्वायर भनेको we can write this है, so we can write this square मात्रै है, so यस्तो हुन्छ रे. If theta is 0, the value of A is the maximum. If the theta is 180, then it's minimum. Lots of thing to remember. No. Okay, vector geometry we'll do in another class. Okay, what is this? Let's see. So up to now we just learn about the vector product and their properties, as well as like condition. If it's 90 degrees, then the value is 0, right? So thank you for watching. See you in another video. Bye bye, take care.